Hello and welcome to Data Driven. In this episode, Frank and Andy speak with researcher Matteo Interlandi about Project Hummingbird. Enjoy the video.
Hello, and let me make sure we are recording. Hello, and welcome to Data Driven, the podcast where we explore the emerging fields of data science, machine learning, and artificial intelligence. If you like to think of data as the new oil, then you can consider us Car Talk, because we focus on where the rubber meets the virtual road. And with me on this epic road trip on the information superhighway, as always, is Andy Leonard. How you doing, Andy?
I'm well, Frank. How are you?
I'm doing all right. We're recording this on Wednesday, September 1st, 2021, and the the remnants of Hurricane Ida are ripping through the DC area. So if I suddenly get dropped, that's because we probably lost power, but I do have the backup generator, the one that the professionals installed, and my duct tape together solar generator. So I will be offline for a short bit and hopefully come back online. How are you doing, Andy?
I'm doing all right, Frank. Well, we are, I'm about, 250 miles south of you. We didn't get near the effects of Hurricane Ida as you did. We're getting a little bit of rain now. We've had some wind gusts, but it's been really mild. And if you look on the radar, kind of watching the track, and I do, I'm a weather weenie, an amateur, but it just kind of went around us to the west, and it actually started east when it got a little north of us and aimed right for your house. I was looking at it, I was good. That's where Frank lived, right? And look, the eye is coming right for Frank. What's left of it?
Well, fortunately, we're safe. There was some kind of flooding in Rockville, and this overnight, and some folk they got up. No one died that I'm aware of. So it's just, we're not accustomed to floods or hurricanes or tornadoes up here in DC. Right. And we're more used to the human threats of little things like terrorism and things like that. But
yeah, you guys got a little bit more to worry about that than we do here in Farmville,
right?
But these days, who knows? The definitely our thoughts and prayers are with the folks in Louisiana and Mississippi. They were hit very hard. I've got friends in Georgia, Western Georgia, were telling me that they took a beating as well, and it looks horrible. I've been in a few of those places after hurricanes have hit, as part of like church efforts to help clean up and stabilize and stuff like that. It looks like, I don't know. People describe it as like a war. I've never been in a war, so I don't know. I've seen pictures, and
right.
It looks like a lot of stuff is blown over and that sort of stuff. It's just so, and they're talking weeks and weeks before power comes back on.
That's horrible.
Some of those places.
Yeah, that's probably going to do more damage for a lot of things.
Well,
but on a more positive note,
on a positive note,
I am super excited to have a special guest, and I say super excited because he's from Microsoft. He's a senior scientist in GSL at Microsoft, working on scalable machine learning systems. Before he was at Microsoft, he was a postdoc scholar at the computer science department at UCLA, and he was doing a lot of interesting stuff there. He was doing research at Qatar. I'm not sure how to say that exactly, but he has a PhD in computer science in the University of Modena, I'm going to botch this, Reggio Emilia. Welcome to the show, Matteo.
Thanks. Thank you.
Awesome. So we are really excited to have you here. We actually booked you a whole month in advance. I've been looking forward to this because you're coming by way of some of the folks at the MLADS conference. And for those who don't know, I've mentioned this. MLADS stands for Machine Learning and Data Science Summit. It used to be in person. I think now it's entirely virtual for the foreseeable future. But I attended MLADS in 2016, summer of 2016, and it was life altering. Like, I don't say that lightly. So Microsoft does amazing work in the machine learning and data science space. very much cutting edge stuff, very much, I wouldn't say under the radar, but Microsoft does not do a great job tooting its own horn. So we're very excited for you to come on, Matteo, and talk about this little project that you're working on. And what is is it have a code name, or what is it called?
Hummingbird. So the code name is actually Hummingbird. Yeah. We
Interesting.
don't have any specific internal names for this.
Okay. What does GSL stand for? That was my first question when I saw your bio.
It's for Gray System Lab and is after Jim Gray.
Oh,
Which
okay.
is Turing Award. Yeah.
Okay.
So it's a research lab after this name. Yeah. And this within the Azure Data Organization.
Interesting. And so what cool stuff does Hummingbird do?
So Hummingbird is a little bit a weird project in the sense that when we started this project, we didn't know if it was going to be a success or not, because what we try to do basically is to translate traditional machine learning models and into neural networks. Actually, not into neural networks, but into tensor programs, such that then we can run over tensor runtimes such as PyTorch and TensorFlow. So when we started this project, actually the idea was, hey, there is a lot of investment in general pouring into this neural network frameworks. And coming from the Azure Data Organization, instead, we are more interested in these traditional machine learning methods, such as decision trees, linear models, one-hot encoding, all those boring traditional algorithms. And so we look at this the neural network system and say, hey, how we can take advantage of all this technology that is built into this domain. So you can run neural network over CPU, you can run neural network over the GPU, then you can use like fancy compilers to compile, to generate the tensor programs, all those sort of techniques. And we were kind of struggling to see what we could do with this stack. And what we come up with is this Hummingbird project. So we basically take traditional machine learning pipelines composed by featureizer and machine learning models. After the day trained, so first you need to train it using scikit-learn, ML.NET, or one of those traditional machine learning platforms. And then once it is trained, we basically convert it into a set of tensor operations. In the current version, we use basically PyTorch for doing this conversion. And then basically you have a PyTorch model, so you can do whatever you can do with PyTorch models. So you can deploy it into PyTorch deployments. You can run over CPU, you can run over the GPU, or you can do the torch script if you want to get rid of all the Python dependencies and just have a C++ program. You can do all those tricks.
Interesting. Does it impact accuracy, precision? Does it improve it, keep it the same?
We try to keep it the same. So we are able to keep it the same up to floating point numbers roundings. So since we use, we use PyTorch to run these programs and not like scikit-learn or ML.NET, there are some differences on how they do, floating point operations. So the accuracy is up to roundings in the floating points. Which sometimes are actually, it can be quite a bit, but most of the time is really small, almost not noticeable.
Interesting. Would you know if there was like a discrepancy, or that's just part of testing?
It's part of testing.
Right. All software is tested, right, Andy? Sometimes intentionally. Is that the?
That's right.
Andy has a saying where all software, I forget exactly what it is, but what is it, Andy? Yeah,
all software is tested, some intentionally.
There you go. So what's the real what are the advantages of converting kind of a traditional model over to a tensor model? Is it portability? Is it speed? You did mention that you can run it on, you could take advantage of GPU as well as CPU.
Yes, exactly. So mostly is related to speed. So you can basically run your scikit-learn model on GPU end to end. And this usually provides, a little bit of quite a bit of speed up. For some of our example, we even saw like a 2 order of magnitude speed up for some of the models, and usually we try to show that if you use GPU, you can be much faster, but on CPU we try to be kind of as close as possible scikit-learn or the base model. Sometimes we can, sometimes we are a little bit slower. But we had some really interesting result. Like for instance, we did some experiment with some folks at the TVM, and we took some XGBoost model and we compiled some trainer XGBoost model using Hummingbird and TVM into some. We basically do code generation, and we show that that model that was compiled through PyTorch and TVM was even faster than the current C++ implementation that they have in XGBoost, both on CPU and GPU. Yeah, there was kind of, okay, what's going on? This is not.
Wait, did you say it was faster than a C++ implementation?
Yes, I mean,
wow.
XGBoost underneath is C++. Even scikit-learn, they use like C++ library, and yeah, using TVM for doing the code generation, they are able to do like a operator fusion, which you don't normally have for like these traditional models. So with all these tricks, basically that are coming from the neural network frameworks, we were able to get like this surprising numbers.
Interesting. So that's a real performance boost, and probably if you scale that up into the cloud, that probably means a lot of money saving too in terms of cloud compute and things like that. I imagine a company like the size of Microsoft would be very interested in getting better results faster with less cloud compute. You did mention an acronym. Just want to make sure folks know what that is. TVM. What is that?
I don't know what it's exactly for. Some tensor.
Andy looks like he knows, but he's on mute.
I don't. Yeah, I don't know.
Okay,
I'm
just
gonna
curious.
look it up.
There you go.
TVM acronym.
I think it is for tensor virtual machine, but I'm not sure. This is a project.
Sounds about right. Tensor vector machine.
I see. So thanks very much comes up. That's interesting.
Okay. Well, we'll figure out what it is and put it in the show notes.
Tensor in here. Now, TVM, you said?
Yeah.
Yes. It's a project. It's a GitHub project. I think it also is Apache project, and is
they're tvm.apache.org. Yeah. And it doesn't tell me what it stands for, but that's where you can go and learn more about it. It's according to the website, an end-to-end machine learning compiler framework for CPUs, GPUs, and accelerators.
Interesting.
It does sound interesting, yeah.
That's what's great about this space. There's so much you could geek out on and spend like. Like I'm just looking through. I found some an article on machinelearningknowledge.ai about Hummingbird, and it's just like wow. It looks like they copied and pasted the FAQ from the official documentation, but it does look fascinating in terms of what it can do. So what motivated the creation of Hummingbird?
So the motivation was actually different. So the initial motivation was actually try to do not to accelerate actually the traditional machine learning pipelines, but to use differentiation. Basically, all this back propagation, all these tools that are using for training over neural networks, and try to translate them over traditional machine learning models. So try to do basically back propagation over scikit-learn pipelines, and that is the base tool. So we started with that base tool that we basically was translating these traditional machine learning pipelines, these scikit-learn pipelines at the beginning into PyTorch, such that we can do end-to-end differentiation. But then once we were at that point, and of course, as you can imagine, we were trying to do end-to-end differentiation for increasing accuracy of the pipeline, to see whether if you use back propagation, you can increase accuracy. And then once we did this translation, we basically realized that, okay, since we are on PyTorch world, we can exploit all these other, the PyTorch framework and hardware acceleration, all those other toolings. And then basically we kind of ditched this idea of doing end-to-end differentiation, end-to-end propagation over the pipelines. And instead we focus more into building a system for accelerating inference prediction over these traditional machine learning methods.
So I'm curious, Matteo, this is not my forte. Frank's the data scientist of our pair here. I am a data engineer. So can you give me an example of a problem that I get the speed part of this. I really do. We need that in data engineering too. I think everyone needs that performance part. But can you give me an example of something that you've applied this to? And you already gave us a interesting number about how much faster it was, a couple of good references on that. Was there something in particular that you've worked on or that your team has worked on and applied this and saw some interesting results?
So Andy, first of all, I'm a database person too. I'm not a machine learning person.
Okay.
So I think we speak the same language.
Okay.
I'm a database person that I'm trying to basically understand all the machine learning domain and see how much databasing can take advantage of these techniques. Nice. And my initial, the start of my investigation was traditional method, because those are the one that you, in general, use over tabular data. That is the one that we care the most. And so related to use cases, let me think. So we try to use it internally for some of our first-party customer, just because they have like scikit-learn models and they want to kind of try to see if they can speed up the inference of this, the prediction over these models. We had someone reaching out from outside, mostly with kind of try to accelerate like a tree-based algorithm, such as gradient boosting, like GBM, XGBoost, those algorithms. And in general, the use cases are really simple. Is you have a scikit-learn models and you want to deploy your scikit-learn models. And when you deploy, you want to take advantage of GPU, either because you already have some GPU deployment, so you already have some neural network there, and you also want to take advantage of the GPU that you are in your deployment with these traditional models.
Gotcha.
Or just because you have like a traditional model, you want to increase the inference time. I have to say that most of the performance boost we usually see is related to batch inference. So not when you're doing one single point inference, but right, when you have like a batch of records that we can basically saturate the performance of a GPU hardware, for instance. So
just to follow up on that, then it sounds like a lot of what you're doing is, you're focused on the tool that does these translations for you into other platforms, other technologies, allows you to use, GPU versus CPU. And I think what you're creating, if I understand you, and I didn't do my homework, apologies. I think what you're building is a way to exactly what we were joking about earlier about testing. You want to see how can I get the peak performance for this part of that, maybe this module or this operation of the batch, and maybe the answer here, and you mentioned this, maybe the answer here is CPUs or GPUs, maybe it's C++, and you're just able to kind of pick the high spots and say I'm getting, or in the case of performance, the low spots, right, the stuff that runs the fastest, and then you can put that together and hand it back to your client or someone who's interested in it and say, right now, given the volume and the data and the state of hardware, you can get the maximum performance if you do this part here, and that part there, and that part there. Is that fair? So you're actually looking into some future work that we are investigating now. So kind of mismatching the different part of the pipeline. So what we focus actually right now is try to translate the machine learning models end to end. So taking the featureizations and all the models end to end, because basically we saw that is the where we can get
most of the time that is where we can get the maximum performance, because
Okay.
by looking at the model end to end, we can run it completely over the GPU instead of having to go back and forth from GPU to CPU, for example.
Okay.
But what you point out is something that we are considering. So kind of look at the model not as a kind of, you know, a unique black box kind of artifact, but is something that we can actually split in different parts, and eventually we can run it over different hardware, over different runtime, such TVM, as I said before. So some part you can run on TVM, some parts you can run on PyTorch, those sort of things.
Okay. So it's
kind of like a meta
combination.
optimizer.
Like, that's exactly
Yes.
where I was going. Yeah, it's like you're tuning stored procs, Matteo, and you're deciding, I want this one to run on SQL Server. I want that one to go to Postgres, and yeah, it just that is interesting that you can span hardware and software. You can pick platforms in the software and do it. And I'm with you. I got my head around this now, and I think that's really, really cool. This just sounds like something that's going to accelerate the field, really, because the last time you're sitting around twiddling your thumbs, waiting for a result, you know, the more you can get done. I mean, that's just common sense.
Yeah,
So,
yeah, exactly.
I love what you guys are doing. That's really cool, and I like that. I don't think I've ever heard anybody talk about, you know, changing libraries and changing, you know, hardware platforms. Even, I mean, it's hard to even say. I don't know what you'd even classify that as, because running different chips, you know, running the processes on different chipsets, that's something we used to do back in the 70s, you know. I mean,
I was
but
gonna say that harkens back to like the mainframe days.
it kind of does. I mean, the 6800s and the Z80s and all of that. But I mean, this is way, way, way more advanced than all that. But I like the idea. I like being able to do that. And I hear what you're saying right now. You're just after picking a platform, picking an approach, and saying, you know, we're going to run this. We're going to generate C++. It's going to run on CPUs, and that's overall that's going to be your fastest result. And it's going to give you your best performance. I get you, but that I didn't realize I jumped ahead there. But that happens sometimes. Rare, but it happens. Y'all can totally take that idea, Matteo, and run with
Yeah,
it.
if you, we can write a paper together if you want to.
There you go. You can write a white paper.
Yeah, I could do the punctuation.
He's really good at reviewing stuff. I will say that. Personal experience from him reviewing my articles in the now defunct MSDN magazine.
Yeah, I remember that. Those were fun. I learned a lot reviewing your articles, Frank, because you were
cool.
always on the cutting edge.
I try.
So, yeah, neat stuff.
But this Hummingbird stuff looks really cool. It looks like it's as easy to install as pip install Hummingbird. Hummingbird-ML, I think it is.
Yes. Yeah, the Hummingbird name was already taken, of course.
Well, yeah. But no, this is really cool. Like I like where this is going. I like the potential for it, because with the cloud, you know, you think about database as a service. Like you don't care what the I mean, you care, but I mean, like from the end developer's point of view, they won't necessarily care what type of hardware. Like this does open up some very interesting possibilities. Just kind of piggybacking on kind of what Andy said, it's like, wow. I mean, one of the things, and I forget who said it, might have been Kevin Hazard, who said that, you know, now we live in an age where we're not dealing with just spinning platters. We can imagine what database, I'm butchering what he said, but he did say, he says a lot of profound things. And one of the most profound things he said was something like, you know, what would a database in the future look like, because we're not dealing with spinning platters? Did I get that right, Andy? Or something along those lines?
You did. He blogged about it out at devjourney.com. We'll have to look that up for the show notes. But Kevin is one of those. He's a pretty profound thinker, and
I was gonna say he's a very deep thinker. Like he's always like 10 moves ahead.
Yeah, and I could tell reading the article, because I've known him and so have you. We've known him for a decade or more. He was struggling with trying to articulate the concept. And if it's tripping someone like Kevin Hazard up, it's a pretty powerful concept.
Right, right.
But he did a good job in devjourney.com. He's not blogging as much because he's just too stinking busy. But yeah, you're right. And I had a similar conversation with with my son Stevie Ray not too long ago. We were talking about you know flash drives and that the memory that we have now that's so much faster than the platters. And I made this comment to him, and I kind of stopped and thought, I don't know if that's accurate or not. And maybe Matteo, since you're here working on the cutting edge, you can help us. We were just poking around thinking about operating systems, and we do a lot or here at the house in Farmville, Virginia with IoT. In fact, he's building a new collection of sensors for me right now for an Arduino. We're going to hook it to a Pi because Pis can talk to, to the internet. They can talk to our router. And that's the next big secret. Don't tell anybody. Kidding. But it's one of the neat things about these Pi architectures versus even really powerful servers that we have right now is both, you can compare them. They're both messaging systems. They're just passing around messages physically on a bus when you get to that Pi level. And that's how I learned it. So I'm really excited about him learning it that way. But nobody thought about, because we couldn't conceive of it when hard drives came out. Nobody thought about building the OS or something second generation or higher language on that without those spinning disks. And here's my long-winded place I wanted to get to is I don't know if we're there now. Even I imagine there's probably some OSs out there that are sitting on GitHub. There's probably 100 of them by now that people are exactly doing that. They're taking advantage of the new IO, if you will. But I don't think the big systems are doing it. I don't think the major popular operating systems are. And for good reason, they're stable. It's hard to change.
There's a lot of
that.
inertia when you have a widely deployed operating system. You get a lot of inertia, and I'm not talking about just Windows. I mean iOS. I mean Android.
Sure,
I mean Linux.
sure.
Like once you have a wide install base, you lose the ability to be very experimental.
Yeah, I totally concur with that. And I see the cloud, I see Azure, I see this leap that's happened, and it's crazy to try. I don't even keep up with it, but just reading tidbits, editing Frank's articles and the like, it's just taking these quantum leaps. It's like 10 years worth of stuff happening every 6 months or something. And you guys just keep knocking it out. And I imagine at the Gray Systems Lab that you're surrounded by people who are just, in Star Trek land or something. I mean,
Yeah, I totally agree. All the things that you said. Like I was presenting a project related to Hummingbird actually kind of a few days ago, and I was preparing my slides, and I come up with this slide. I think it was from Jeff Dean a few years back, and it basically was showing the number of papers that were published on machine learning or publicly on arXiv, and in 2018 they were published 100 papers a day. Just on machine learning on arXiv. just to give an idea on how fast is now the pace in which innovation is coming up, especially in the machine learning neural network domain, is just crazy. On operating system database domain is a little bit slower, I would say, because as Frank said, there is inertia there because these systems are deployed, and if you want to add even new hardware, it takes forever. So I say in Microsoft, what happens when you have like a new hardware coming in and you want to exploit it, it just takes forever. And this is just because, they're used by many people. And even if you want to do a small change, it's really hard.
And I'm seeing the articles about Windows 11 where when you try to make a change like that and say, hey, you need this minimum hardware now, everybody's going, what?
Oh yeah. Everybody's got the pitchforks out and like freaking out and like, yeah. I mean, I remember I was at Microsoft doing evangelism on the shift to Windows 8, which just you would not believe this. Well, maybe you would. I don't know, but like just the horror in people's faces when they got rid of the start button. Like it was like the end of the world. Like you were killing somebody's grandma. Like it was just like. It was just like, I mean, I disagree with the decision that was made, but let's put it in perspective here, you know.
You can
But
still
yeah,
get
I
there.
mean,
You can still start things.
right, you can still start things like and before, this is funny, like this is just a complete sidetrack, and Matteo, we do this a lot.
I was going to, it never happens, Matteo. Just for
Before
you,
keyboards
we're gonna
had
go
the
up
Windows
sidetrack.
key, you could hit Control Escape and it pulls up the same thing. Like I don't know, like it's just not the end of the world. Anyway, sorry, flashback to 2012. But so Matteo, we have a bunch of kind of pre-canned questions we're going to ask you. We asked this from all of our guests. Most of them, or about half of them, are kind of fill in the blanks. But the first one is, how did you find your way into data? Did you find data, or did data find you?
I would say data find me. I think it was mostly because when I started my PhD, I wanted to do distributed systems. And for some reason, I ended up doing distributed system in a lab, in a database lab. So I think that is why I think data found me, because I wanted to do something else, but then I ended up doing data. And that probably was, I was really lucky, to be honest.
Cool.
Very cool. So our second question is, what's the favorite part, your favorite part of your current job?
I don't know. This is a hard question. I would say that I really love my management in the sense that they allow us in GSL to be sort of independent in the sense that, we are researcher and
Sure.
they allow us, they find a way to kind of strike a balance between having us be independent and kind of do our own research with crazy ideas like the one that I presented with Hummingbird, and still be kind of, with our foot on the ground and kind of help a product improve the system, etc. So I think that is mostly what I love. So on one eye, I can kind of look in what we can do next, like having the operators running over different hardware. And with the other eye, I can kind of see what are the real problems that are coming from product and how we can solve them. And I love this, to be honest. I love this.
Nice.
Awesome. Our first complete this sentence. When I'm not working, I enjoy blank.
I would say work, but they will not sound bad. Yeah, I don't know. Maybe family at this point. Maybe family. Spending a lot of time with family. With the COVID time, we are often at home, and I have a 2-year-old that is driving us nuts. So.
No.
That's pretty cool.
So
My
youngest did Zoom, kindergarten over Zoom, and it's just as chaotic as it sounds. Let's put it that way.
Yeah, I cannot imagine. I mean, to be honest, now he's in daycare, and we are really happy that now he's in daycare because, at that age. But I guess that every kid needs to have interaction with other kids, and just stay at home is not healthy. But I can imagine how hard it is to have like 1 year at home and having classes through Zoom calls. I hope that this will happen.
Go ahead. I'm sorry.
No, I said I hope that this situation will end soon.
Me too.
Even if it doesn't like to, but
yeah, same here. I think we all do. I think it's going to be one of those things where we look back for decades probably and see these little things that we're really not noticing right now. We're just coping and managing and going on. That we're going to look back and go, wow, that changed this and that, and there's all these things that come from it. I hope mostly good, but I think it takes us time to figure out the good. So
I agree.
I look forward to that time when we are reflecting and reminiscing on stuff like this. I want to, but we have to be on the other side though.
Yes. Unfortunately, yes.
Our second of 3 complete these sentences is, I think the coolest thing in technology today is blank.
I don't know. I mean, as a researcher, usually I'm attracted by things that I don't know. So we'll say something like quantum computing, because I don't know anything about quantum computing. Yeah, I don't know.
So go to impactquantum.com.
I'm smiling because I was waiting for Frank.
It's funny because I went to the last MLADS that was held in person. It was fall 2019. And the second day keynote was a hardware keynote. And, I go to a data science conference. I want to learn data science. Like I was kind of mad that they had a hardware person up. But then she started talking about quantum, and it was just blew my mind. And ever since then, I've really wanted to, I was just so overly excited about like quantum computing. But the thing about quantum computing is, that night at the hotel, like, I installed the Q Sharp SDK and stuff like that. And then I was like, okay, now what? Because it made no flipping sense. So I've been kind of on this, intermittently this journey of kind of learning more about quantum computing. So starting the podcast on, Impact Quantum, and then starting kind of like the blog have kind of forced me to keep at least a regular cadence of figuring out what's going on there. So it's fascinating. I will say the one thing I've learned is the importance of linear algebra. Apparently, linear algebra and the way the algorithms work in quantum systems tend to explain each other very well. So, but yeah, so definitely impactquantum.com is a blog I've started last week, and regularly updating it, put that way. But that's, ending the shameless plug. But I agree with you. I think quantum computing would be a very cool thing to explore for a number of reasons. The next and final complete the sentence is, I look forward to the day when I can use technology to blank.
I can use technology and I cannot have to drive the car. That is like
Yes.
self-driving cars is something that I live in Los Angeles. So for me, self-driving cars can be kind of completely life changer.
Yes. I totally agree. I used to enjoy driving. Like I didn't have a license until I was like 21. So like, it was just like, for me, I'd done my time on mass transit. Let's put it that way. But like living in DC, everywhere is just bumper to bumper, to do probably a lot like LA. And it just really takes the joy out of it. And, um, one of the things, my last job at Microsoft, I was at the MTC, and the only thing I didn't want to take that job was because I had to drive to Virginia every day, which, despite it being 9 miles as the crow flies, could take 90 minutes to 2 hours. But as I don't want to say as luck would have it, because it certainly wasn't lucky, the pandemic kind of made it so I could work remotely, and never had to do it. But I share your dream, Matteo, of the driverless of the self-driving car. So you can read, you can be on the computer, you can do work while you're driving and things like that. Yeah, I'm right there with you.
I totally agree with what you said. I mean, I'm from Italy, and I'm from Modena, which is where basically we say we like a fast car and good food. So we have like Ferrari, we have Ducati, we have
nice
Maserati. They're all built over there. So I was growing up with like hearing the Ferrari when they tried in the circuit that they have in Fiorano. I live like I think 3 or 4 miles from Fiorano, and still I can hear when they turn the engine on how loud was that. So I really like cars, but yeah, I cannot stand like sitting, idle in the traffic, buying with other cars just for instance, for going to work or for going grocery shops. And it's just kind of a waste of time.
Especially Ferrari. If Ferrari's meant to go run free.
Yes. Put that thing in Texas.
That's right. My neighbor, a couple of my neighbors have, one of my neighbors has a Ferrari, and you can hear it go by. It sounds beautiful to hear it go by. So I totally relate. Somebody down the street owns a Jaguar V12, and when that thing goes by, it's like angels singing. I know it's a British car, not an Italian car, and that's probably heresy, but I will say it sounds impressive. So it sounds like you might also be a car guy, or at least used to be.
Sure.
Yeah,
used to be.
Very cool. So our next one is share something different about yourself, but a little caution. It's a family-friendly podcast. We want to keep that iTunes clean rating here, so don't make us edit.
Yeah, I don't know. I mean, I don't know what about to share. Really, I'm kind of spending all my time either I work with or with family, so I probably have the boring life ever. The only thing that I think it is good. I mean, I don't know if it's good. The fact that now we are working from home, I have kind of more time to focus on other different things. Like for instance, I can watch stocks. Why before I couldn't watch stocks and while I was at work. Because I can have my laptop, and when I have a meeting, I can just take a peek. And of course, I can have my stock there while I'm working.
Nice.
And yeah, and I think I kind of like kind of looking at the stock market, especially because now is there is a little bit of fraud around. So all this meme stock, etc., is it make exciting, but also a little bit dangerous. So.
It's become like a sport, if you will.
Yeah, I mean, I was trying this the Robinhood app. When they say gamification of stock market, I don't know if you ever tried that. Is crazy. It looks like gambling at all.
Right.
It really looks like gambling. Yeah.
And the final question, do you listen to audiobooks? And if so, do you have any recommendations?
No, I don't listen to audiobooks. I think I'm more kind of on the old style, I would say. I prefer usually to read rather than listen. To be honest, I don't know why. I don't know why.
I think it depends on the person. Like, I think it depends on kind of what you're comfortable with. I mean, my audiobook listening is nowhere near where it was when I would drive everywhere all the time. So, yeah. So the reason why we asked is because Audible is a sponsor of the show. And if you go to thedatadrivenbook.com, you can sign up for free Audible membership. And if you sign up, then they give us a little pat on the back and probably enough money to buy a Starbucks and help support the show. And they've actually been one of our #1 sponsors so far because of this program. So,
Yep.
So you mentioned you had a website. Where can folks find out more about you?
What is my website? I think it is. I don't remember. Interesat is a GitHub website. Interesat.github.io.
All right, we'll make sure it goes on the show notes, so folks can find out more about this. And definitely go to your favorite command line prompt and type in pip install hummingbird-ml to check out what's going on. I'm definitely going to experiment with this because it does look fascinating, and like Andy said, the potential for this is fascinating, because this could end up in a lot of different places because it solves a lot of different problems. So, anything else, Matteo?
Yeah, if you try it, let us know, and we are kind of looking for contributors and feedback. So if you try it, let us know what do you think and how we can improve.
Awesome. Thanks, and I'll let the nice British lady end the show.